Hello, welcome back. So this should be a pretty short video. We're just going to run through that flow chart that you have in your book on the male reproductive hormones. There's a chart for both female and male reproductive hormones. So in the kind of in between the end of spermiogenesis and the beginning of hormones, the notes in the book talk about the accessory glands. So make sure you kind of read through those, see where you can identify them anatomically and what the role of their secretions are for the contribution to seminal fluid, the volume of seminal fluid, kind of their role in helping to activate sperm or be protective of the sperm as they're going into the female reproductive tract. Okay, so let's take a look at the hormones. So I'm just going to go through this flow chart like I normally would have maybe in class, pick one at a time and just kind of go through this and then make sure all the pieces have been touched on. So we got to remember a little bit back to our endocrine system from 232. So we mentioned testosterone and estrogens and progesterones as the reproductive system hormones, but we didn't spend a lot of time on those back in 232 because I knew we were going to do that now. But we did talk about the hypothalamus hormones and the pituitary gland hormones. So if you remember, the adenohypophysis, which is our anterior lobe, right? Adenohypophysis is the anterior lobe of the pituitary gland. It secreted 7 individual hormones. And if you remember, it released LH and FSH were part of that collection. LH was luteinizing hormone and FSH was follicle stimulating hormone. So males and females both produce those, even though they kind of tend to have more of a femaleness name, like follicles are in the female ovary. Luteinizing hormone is more of a female characteristic. So we have the luteal phase. And my guess is they probably identified those hormones in females first and then also saw that they were in the male pituitary gland as well. And then because these are of the anterior lobe pituitary gland, if you remember, that part of the pituitary gland was regulated via the hypophyseal portal system from the hypothalamus. So again, if you wanted to pause here and go back and review chapter 18, just kind of reread that section, that's totally fine. But basically the idea is we have hormones in the hypothalamus that travel through that little portal system from capillary bed to capillary bed via these vanules that will then go and regulate the FSH and LH. So that would be hormonal stimulation, right? Humoral, neural, and hormonal. So a hormone from the hypothalamus is stimulating the release of hormones in the pituitary gland, hormonal. And that hormone that is going to be regulating LH and FSH is GnRH. It's called gonadotropin releasing hormone. Now, why is it called gonadotropin? Is because if you remember, tropic hormones were hormones that triggered the release of other hormones. So the gonadotropic releasing hormone is a hormone that comes from the hypothalamus that triggers the release of other hormones, FSH and LH. And again, we also have GnRH in the female hypothalamus as well. We're going to see that in that part of the mini lecture. So when GnRH is released from the hypothalamus, it travels down that hypophyseal portal and it stimulates the secretion of LH and FSH. And so we can see that with the red arrow. So if you look at the key down here, red arrow means stimulation. So we're just going to pick one, follow that through, and then we'll come back and cover the other one. So I'm going to start with LH first. So when GnRH is released from the hypothalamus, it's going to trigger LH. LH travels through the bloodstream and targets interstitial cells of the testes. So remember, testes are primarily the seminiferous tubules, tons and tons and tons of tubules, and then squished in between interstitial, in between those seminiferous tubules, we have the interstitial cells. Interstitial cells, their responsibility is to produce testosterone, right? Here we go. Now we have testosterone released into the bloodstream. Well, what does testosterone do? It does a lot of stuff. So within the testes, I'm going to kind of stay within this tan box. So within the testes, the testosterone triggers nurse cells. If you have an older edition of the book, they might have been called sustentacular cells, which is a really long word, so nurse cells is nice. So nurse cells help to stimulate spermatogenesis and spermiogenesis, which we just covered in the first video. They help to synthesize what's called androgen binding protein, which helps to kind of keep testosterone close in that sperm development area, and also helps nurse cells to secrete what's called inhibin, which is another hormone. We'll take a look at that in a little bit later. So within the testes, the interstitial cells release testosterone. It just flows locally to their neighborhood, stimulates the nerve cells to kind of keep those testosterone levels high, and stimulates the nerve cells to help this process of spermatogenesis and spermiogenesis within the testes. Well, but we know testosterone has other functions outside of the testes, so that's going to be following this arrow here. And it's based on kind of that flow chart. It's a broad, lots of targets for this particular hormone. There are effects on the central nervous system, so like libido and motivation and kind of sexuality-driven thoughts and processes on the central nervous system. Testosterone helps to build muscle and growth. That's why it's abused as a steroid for people who are wanting to increase bone and muscle growth. It helps to establish, especially during puberty, and maintain secondary sexual characteristics. And then it also does some maintenance of those glands. So the prostate gland, vulvourethral gland, seminal gland. So that's all going to be aided by the secretion of testosterone. Now in humans, we do not have such diverse sex roles, if you will, as far as appearance goes. So males, they can grow facial hair. Their musculature is kind of distributed differently than females. Sorry, I had to pause there for a second. Got something in my throat. So in the animal kingdom, however, there's quite a big diversity in this dimorphism is what it's called, when there's two distinct phenotypic appearances. Like in birds, think of like male birds are very colorful and really fancy feathers, and female birds are usually a lot more muted. Male lions have a big mane, female lions don't. So those are secondary sexual characteristics. We don't really see that too much in humans, but there's a few more subtle characteristics that can be maintained by the testosterone. All right, so that's the role of the LH. Think of LH triggers testosterone. That's kind of your big key. And then what does testosterone do? Helps with sperm production via nerve cells, and helps, wide kind of systemic results with CNS, bone and muscle, secondary sexual characteristics, and reproductive system glands. So if we go back to our hypothalamus and our pituitary gland, we're going to secrete now FSH, which is our follicle stimulating hormone. So that is coming from your anterior lobe of the pituitary, goes through the bloodstream, targets your seminiferous tubules, specifically the nurse cells, and they are also being stimulated by some of the testosterone. So the nurse cells we already talked about help to secrete androgen binding protein, which when the testosterone is also secreted, it is going to kind of hold it in higher concentrations in that area around the developing cells, and it helps to stimulate this process of spermatogenesis and spermiogenesis within those seminiferous tubules. So think of follicle stimulating hormone in men, helps to kind of encourage the production of sperm. Another role of nurse cells is the secretion of inhibin. So here's this other hormone we're going to take a look at. So inhibin, as the name implies, inhibits FSH. And we also have another inhibitory mechanism that I didn't mention earlier with testosterone. So now I have two mechanisms of a feedback loop, a negative feedback loop, because when the GnRH is high, FSH and LH is high, which means you're going to have high testosterone and high inhibin. When you have high inhibin, it's going to decrease GnRH and FSH and LH, which is going to bring those levels down. So the negative feedback is down. So if you are not inhibiting the hypothalamus and the pituitary gland, those levels go back up. So men, it's a lot more obvious in female cycles, but there's some subtlety to cycles in men. So if you have high levels of testosterone, which is going to be high levels of inhibin, that's going to trigger a decline in FSH and LH, which is going to trigger a decline in testosterone and inhibin. When those things are low, the inhibition stops. FSH, GnRH, and LH all go up, so then your testosterone levels go up. When testosterone levels go up, you get negative feedback. So we kind of have this dynamic between probably an upper limit and a lower limit where your testosterone levels are going to fluctuate within an acceptable range. So it's not just a steady state, solid line of testosterone. It fluctuates probably throughout the day. All right. Okay, I think we got it all. We covered LH, which is your testosterone stimulator. We covered FSH, which is your nurse cell and spermatogenesis stimulator, and inhibin, which comes from the nurse cells, inhibits FSH, while testosterone inhibits your hypothalamus. But it's kind of this negative feedback loop to maintain dynamic equilibrium of your sex hormones. All right, so that wraps up the male section onto the female reproductive system. Bye.